Hi everybody, welcome back. We're going to do another example with this graph. You'll see here's the equation. I've graphed it for you, and we're going to list the transformations and whatnot again. So just more practice doesn't hurt. So the transformations are going to be, it's negative in front, so again it's a reflection about the x-axis. You can clearly see that it's opening downward, right? What else do we have? We have a vertical stretch equal to 1. You don't see it. Remember, it's negative there, and there's a 1. We don't see a 1, so it is 1. We also have a vertical translation, and that's equal to -1. Oh, equal to -1. And we have a horizontal translation equal to 1. So lots of 1s, just a coincidence. Next, we'll do the mapping notation and the table of values. I'll do that together as one. So here's your table of values. I'm going to enter the points, and these are just copied from the last one. So it's negative 2 plus 1, so that's going to go up. That's going to be 0. That's going to be your x, your y-intercept. 1, 2, 3. And put in 4. -4 plus 1 would be -3. -1 plus 1 would be 0. Put a y value in -1. This should be -1. I do apologize, which would make that -5. Little typo, no big deal. So that should be negative minus y -1, obviously for the mapping notation, because the vertical stretch was 1. So it's right in here. It's negative because it's a reflection. It's +1 because the horizontal translation is 1, and the vertical translation is -1. So that was my mistake. I do apologize. So that would be -2 because of -1 minus 1 more. 0 would be -1, and then we're coming back up, so that would obviously be -2, and this would also be that would be -5, right? So there's your table of values. Again, I'm just plugging these coordinates in to our mapping notation in order to get our new coordinates of our graph. Make sure they look correct. Vertex is -1, -1, which is clearly here. Y-intercept is 0 and 2, clearly here, and -1, or -1, -5 is here. So it looks good. For sure. Let's do the opening direction of the graph. It opens downward again because it's negative. Clearly you can see it open downward. Coordinates of the vertex, so we say V is going to be 1, -1. 1, -1. It's right here. 0 maps onto the vertex, which you can clearly see. It's a maximum value again. So we'll get rid of minimum. It's a maximum value, and that maximum value is y equal to -1. It's the y value of the vertex. Axis of symmetry is your x value of the vertex. So it's going to be x equals +1. You can clearly see there's no x-intercepts. No x-intercepts. And the y-intercept, we can see from our table values 0 and 2 work from the diagram. And the y-intercept is 0 and -2. Domain of range. Steal the notation for domain of range quickly. Domain of range. Domain is going to be the reals again. It's going around for left and right, and the highest y value is -1. That comes from your right here from your maximum value, -1. In standard form, we just grab our equation again and we're going to multiply it out. So changing the forms, there we go. So we just multiply and expand. I'm not going to do every single detail this time. If we square that, we're going to get x squared minus 2x plus 1. That's squaring the binomial, negative 1x squared, negative in front. You guys subtract 1 from it when you're done. Alright, and now we make everything negative in brackets here, so the brackets are going to be gone. Oh. So, there we go. So that would be negative. Oh. Negative x squared, negative negative gives you plus 2x, and the negative's positive gives you negative x minus 1. And then last but not least, we pull it in. Combine these like terms, you get negative 2. So that's your standard form, is negative x squared plus 2x minus 2. And then we'll move on to the next example. Example 2 on page 15. It says a rock is thrown from a bridge in the river. It's given by this equation. Let's do it on our graph calculator this time. So we'll get y equals, clear this, we'll put negative 4.9x squared, and we will add 17 t, which we just put x in, and we add 110. 110 is the y-intercept. So we're going to have to open our window up big time here. So our window is going to be, let's make it negative 5 and 10. For our x scales 1, we'll make that negative 25. I just like to see some negative even though we don't need it. And that goes up to 150. Your scale's 1. So negative 5, 10, 1, negative 25, 150. And we graph that and we get this graph here. Remember, when you're sketching it, we don't need any part of the negative right here. We don't need that. We just want from here to here. So that's why I'm going to grab my Desmos to give me that graph, make it look nice. So for graph, we need it to go 10. So Desmos is pretty neat. You can I'll make it negative 5. It's really easy to use. You can download the app. It's pretty awesome. 15. Oh, positive 15. Sorry. And then the y values go from, we put negative 25 up to 150. Again, this is just to give you some sort of diagram when you're going to plot the points. So there you got this nice graph here. I'll put my equation in just so we can see it going through, and then we're going to plot some of the key points. So y equals negative 4.9x squared, and we have plus 17x. We don't have t on there, so not that it would matter. There we have our graph. All right, and we don't want this part, so I'm not even going to show it. So all we want is that point there, our key points right here. So I'm going to take a picture of that. And there's your sketch. Cut. Remember, we only need quadrant 1 here. We do not need the rest of the quadrants. They're not necessary. And the Desmos, okay, so it says using a graph calculator. There's your graph. We sketched it. So you can just sketch this with pencil. Our key points are 0, 1, 10. That's the y-intercept. That's where it starts. So this red part here that you see, ignore that. Don't have that on yours. There's our vertex. That's going to give us our maximum values, our time, and our height at the maximum value. And then the 6.780, that's our x-intercept. And that will help you obtain your how long it's in the air, right? So it works really well. There's the bell. So we're going to finish answering these questions moving forward. So what's the maximum height of the rock? The maximum height is the y value of the vertex. So you just simply say h equal to 124.7. We'll go one place after the decimal because it didn't ask to put the units in meters. The time it takes to reach the maximum height, that would be again the x value of the vertex, 1.735. So 1.73 seconds. We put t equals, sorry. T equals. What's the height at 2 seconds? So the height at 2 seconds, I'll show you how to plug that in on your graphing calculator. So we go second function calculate a value. The value is we're looking for is when x is 2, which is time. We hit enter and it gives us 124.4 right here. So you can see that. Again, that's on the graphing technology. So to show that, we say the height at 2 seconds is equal to 124.4 meters. The next question says, when does it reach a height of 25 meters? So this is where you do an intersection. You put y equals, and we put our second equation in y equal to 25, and we graph it. So we're looking for this point right here, which is an intersection point. So it's second function calc, intersection. So we go right till we get close to where we're looking for the intersection point. Enter, hit enter again, and enter for a third time. So when the height is 25 on the way down, the time is 6.25 seconds. So the time, it's asking time, when it means time. Time is equal to 6.25 seconds, lowercase t. It says determine the height of the bridge. The bridge is when your height at 0 seconds, that's at the very beginning, which is literally just your y-intercept, which is right here, the initial, so it's the 10. And then the last question says the time it takes for the rock to hit the river. So that is going to be t equal to 6.78 seconds. That's simply the y-intercept. It has now hit the ground. So that's page 15. This example. We'll finish up in the next video with example 3. I hope you enjoyed the video, and we'll see you again soon. Thank you.